guys, welcome back to my YouTube channel. So today we are going to solve day 11 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today we are going to solve problem number 2220, minimum bit flips to convert number. Okay, so this is very easy problem. So in this problem, a bit flip of a number x is choosing a bit in the binary representation of x and flipping it from either 0 to 1 or 1 to 0. Okay, so this is what we need to do. Let's take one example. So for example, here x value is equal to 7. Okay, and the binary representation of 7 is this, like this, right? 1, this bit value is 2, this bit value is 4. Okay, and we may choose any bit including any leading zeros not shown and flip it. We can flip the first bit from the right to get this one. We may flip the second bit from the right to get this one. We may flip the fifth bit from the right, a leading 0, to get it like this. Okay, so I can write 7 like this as well now. 0 0 1 1 1. Okay, so I can flip this bit as well like this, 1 0 1 1. Okay, so all these things I can do. Okay, so I am just flipping the bit from 0 to 1 or from 1 to 0. Okay, this is we need to do. And why we need to do this? So let's understand that. So we have given two integers, start and goal. We have to turn the minimum number of bit flips to convert start to goal. Okay, so that is why we are doing all this stuff. So there is one number given to us, start. Okay, and we want to make our start equal to our goal. Okay, and we can only flip the bits from 0 to 1 or from 1 to 0. Okay, so here first see how I'm going to represent 10 in binary form. So I'm going to represent the 10 in binary form like this. Let's say this bit value is 1, this bit value is 2, this bit value is 4, this bit value is 8. Okay, so to represent 10, this bit will be 1, this bit value is 1. Okay, and here 0 0. Okay, so this is how we represent 10, right? And how we represent 7. So let's fill the values for 7. Okay, so for 7, this bit will be set, this bit will be set, this will be set, and this will be 0. Okay, so now what we need to do here, we need to convert, okay, our start equal to goal. Okay, this is what we need to do. So here see, this is 1 and here it is 0. So one position that I need to change is this one. Okay, here it is 0 and here it is 1, so I need to change this as well. Okay, and this is 1 and this is 1, both are same, I don't need to change it. Okay, and here it is 0 and here it is 1, I need to change this one as well. Okay, so how many bits I am flipping here? 1, this one, and this one, right? Total 3. So see here, the binary representation of 10 and 7 are 1 0 1 0. Okay, and 0 1 1 1 respectively. We can convert 10 to 7 in 3 steps. So we are flipping this bit, we are flipping this bit, we are flipping this bit. Okay, it can be shown we cannot convert 10 to 7 in less than 3 steps, hence we return 3. Okay, so I hope that you guys are clear. Same way for this 3 and 4. Okay, so 3 we are going to represent it like this, and 4 we are going to represent it like this, right? Now we have to convert our start to goal. Okay, so here see here, this is 0 and this is 1. Okay, so I need to change this one. Okay, 1, this is 1 here, here it is 0, so I need to change one more bit, flip. Okay, here it is 1, here it is 0, so I need to change one more. Okay, so total 3 bits I am flipping right here, this one, this one, this one. Okay, after flipping all this bit, I will get my start equal to goal. Okay, so now let's understand the approach, how we are going to solve this problem. So let's take this example, start is equal to 10, start is equal to 10, and my goal is equal to 7. Okay, so let's first try to solve this problem using approach number 1. Okay, so you guys must know what is XOR operation. Okay, so in XOR operation, let's say A and B, total 2 values are there, then what will be their result? Okay, so let's say this bit value is 1 and this bit value is 1. Okay, then in that case we have to just give the result as 0. Okay, if both the bits are matching, we have to just return the result as 0. If A is 1 and this is 0, then we have to just give 1. If this is 0 and B is 1, then we have to just give 1. Okay, so this is nothing but my XOR table. Okay, so this thing you guys must know. Okay, so when two bits are same, the result is 0. Okay, when 2 bits are different, then the result is 1. Okay, so now here first I'm just going to do the XOR of my start and goal. Okay, so 10 XOR 7. Okay, so how I'm going to write a 10 in binary form? So I have to write it like this, right? 1. Okay, so let me just give the bit values 1 2 4 8. Okay, so I need to write 10 like this, and I need to write 7 like this, right? Now just do the XOR of these two. So what is the output that I'm going to get? So our output that I'm going to get here is 0 1. Both are different, so write here 1. Both are same, write 0. Both are different, so write 1 here. Both are different, so write 1 here. Okay, so I'm going to get my output as 13, right? 8 4 12 13. Okay, 13 is the output that I'm going to get when I'm going to do the XOR of this. Okay, so can I do one thing here? I can just convert this 13 to a binary string. Okay, and after that I will just calculate the length of this one, and then I am going to iterate over each character and see the count of ones. So count of ones is 3, so I will simply return my output as 3. This is one approach. Okay, so let's write the code for this approach. Okay, so code is just 5-6 lines hardly. Very easy problem actually, this one. Okay, then after that I will discuss approach 2. Int number is equal to start XOR with goal. Okay, then after that we are going to get the bit number. Okay, so I'm converting this bit number, okay, which is an integer format. Okay, this number is an integer form, right? So I am converting this integer to binary string. Okay, to binary string, and in this binary string I am just passing the number. Okay, I will get one string now, string bn. Okay, this is done. Then let's calculate the length of this string bn. Okay, so bn dot length. After calculating the length, let's iterate over all the characters one by one. Okay, in my this bn 2 char array. Okay, this is done, and here inside this we have to check if the character value is equal to 1. Okay, in that case I have to just increment the count value. Okay, so let's initialize count here. Initially this value of this count is 0. Okay, and once all this is done, and then after that just return count. Okay, so that's all. This is for approach number 1. So here, fix this, run it again. So see, all the test cases has been accepted. Now let me submit it. Okay, so see, our solution is accepted, right? So this is approach 1. Okay, so in this approach 1 I am converting this number to a binary string, and then after that I am calculating the length, and after calculating the length I am iterating over my string, and see, I am seeing if my character is 1, then I am just incrementing the count. That's it. Okay, easy. Now let's move to the approach number 2. So in approach number 2 also we need to first do the XOR of start and goal. Okay, so I am going to do this, and I am not going to use this. Okay, I am not going to use this, but directly I am going to run one while loop to calculate. Okay, so let's see how I'm going to solve that. So first thing, we are going to get this number 13. Okay, 13. Okay, I will get this 13 by doing the XOR of 10 and 7. Okay, so this is what we need to do here. So I will get this number. Okay, then after that I am going to check while my number, okay, this number, while my number is greater than 0. Okay, if this number is greater than 0, this is inside one while loop. Okay, while my number is greater than 0, then I am going to do the count is equal to count plus number. Okay, what is my number? And I'm going to do the AND with the 1. Okay, then after that I'm just going to right shift this number by 1. Okay, so let's see how this is going to work. Okay, so first tell me what is that. Right now my 13 is greater than 0. Okay, so number is greater than 0. So what I need to do, I have to do the count. Initially count value is 0, right? So 0 plus number is 13, and I'm doing that and with 1. Okay, so what is the output that I'm going to get here? 13, if I write it in binary form, so I will write it like this now, 1 1 0. Okay, So now do the AND with 1. Okay, so this is 1. This is how we write 1 in binary form. Okay, so what is the output that I'm going to get? So AND operation, 1 1 1. Okay, here it will 0 1 0 0 1 0 0. Okay, AND operation. Okay, when both are 1 then 1, otherwise 0 only. Okay, so this is my AND operation, right? 0 1 0 1 0 again 0. If both are 0 then again 0. If both are 1 then 1. Okay, this is nothing but my AND operation, right? So here I will get 1. Okay, so I am adding count is equal to 0 plus, here this is nothing but 1 number only. Okay, so 0 plus 1 is 1, so I have incremented the count, right? So count is equal to 1. Okay, and then I am just doing the right shift of n. So 13 like this, I will right shifting it. So let me just remove it. So now this is going to be my new number. So here 1 2 4 4 5 6, 6 is a new number. Okay, then I will pass 6 here. 6 is greater than 0. If 6 is greater than 0, then I have to execute this again. Okay, so here last time count is 1. Okay, 1 plus number, this time number is 6 and 1. Okay, do. Okay, so 6, this is 6 now, do with 1 AND operation. So all are 0. Okay, so all are 0, right? I will get 0 now. So I am incrementing, my count will remain same only. 6 and 1 is 0. Okay, so my count will remain 1. Okay, so now again do the right shift. Okay, so then my number will become like this. So this is nothing but 1 2 3. Okay, so then my number will become 3. So 3 is greater than 0. Yes, so a count is equal to 1 plus 3 and 1. 1 plus 3 and 1. 3 is this one. Do it with 1. Okay, so here I will get again 1. So do the 1 plus 1 is 2. Okay, so my count will become 2 here, and then again do the right shift. Okay, so then my number will be this. Okay, 1. So now again 1, count is 2. Okay, 1 is greater than 0. So again I reach here. So count is equal to count is 2 plus 1 and 1. So 1 and 1 both will give me 1 only. So here 3, count will become 3, and then I'm going to do the right shift of number. My number will become 0, and after that I don't need to execute this while statement. So last time my count is 3, I need to just return that. Easy. So let's write the code for this one. So while my number is greater than 0, okay, then in that case count is equal to count plus number and 1. Okay, so we are going to add 1 to count if the last bit is 1, and then we have to just do the right shift of this number. Okay, so we are just doing the right shift to process the next bit. That's it. Now let's run it. Let's submit it. So I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.